Hello and welcome to Chem with Cam. Today we're officially going to start the first series of Chem with Cam with an explanation and definition of some basic terms in chemistry. Firstly, what is an atom? An atom is the smallest division of matter. You may see it represented like this. It has a nucleus in the center. The nucleus is the most massive part of the atom. And when I say that, I do not mean that it is the most huge, the most spacious part of the atom. I actually mean that it is the heaviest part of the atom. The nucleus is made up of two other types of particle, called protons, represented here in red, and neutrons, represented here in blue. Protons are positively charged, and neutrons have no charge on them whatsoever. Orbiting the nucleus are the electrons, which have a negative charge and are much, much less massive than the nucleus. One proton weighs about 1,800 times what an electron weighs. So the majority of the mass of the atom happens in the nucleus. Chemistry, as a general rule, is concerned with the juggling about and movement of these electrons. It's basically accounting for subatomic particles. But there's another term, subatomic. What does that mean? Well, literally taken, it means sub, smaller than, lesser than, and atomic, the atom. So these particles are subatomic particles because they are smaller than the atom. This is the atom, these are the subatomic particles that make it up. When you change the number of protons in the nucleus of an atom, you change what kind of element it is. This atom, as you can see, has 3 protons. So this atom is of the element lithium. When you add extra electrons to a naturally occurring atom, an atom becomes negatively charged. And we call charged atoms ions. A negatively charged atom is one that has more electrons orbiting the nucleus than there are protons in the nucleus. This is called an anion. When you take electrons away, the atom becomes positively charged. We call this positively charged atom a cation. This atom of lithium, for example, has 2 electrons and 3 protons. This makes it positively charged. And just remember with cations that you can't add more protons to turn it into a cation. You can only take electrons away. By adding protons, you're changing the kind of element it is. We added another proton to this lithium atom, it would turn into beryllium. So enough about the atom. This is about definitions, not atomic theory. So on to other definitions. What is an element, or a compound? Well, an element is a substance made entirely out of the same type of atoms. They all have the same number of protons in their nucleus. Different number of protons, different element. This is aluminium. You may recognise it as alfoil. There are only aluminium atoms in this piece of alfoil. Therefore, this is an example of an element. Well, how about a compound? A compound is where 2 or more elements are joined chemically to make a new substance. This, my friends, is common or garden variety table salt. It is made of the compound NaCl. NaCl stands for sodium chloride. That might not make much sense, but we will get to that in a periodic table video in a few weeks' time. Elemental sodium, the Na, is a silvery metal which explodes on contact with water. Elemental chlorine is a poisonous yellow gas that kills most people who inhale it within a few minutes. Combine them together with chemical bonds and voila, the most mundane and boring chemical known to man. So if you have sodium metal and chlorine gas and you mix them together, you get salt, right? No. They have to be combined chemically, which means their electrons need to interact in a certain way that I'm not going to go into detail with here. A mixture is where 2 or more elements or compounds come together into the same container and don't react and sort of, well, mix with one another. And they can therefore be separated without playing with the electrons. They can be separated by physical means, like filtration or boiling or something like that. A good example of a mixture is juice. You let it sit for too long, and the heavy bits sink to the bottom, and the light, sweet things, like the sugars, float to the top. That's why when you don't shake juice, and you drink from the top to the bottom, the top of the juice tastes really sweet, but the bottom tastes fairly sour. This is a specific type of mixture called a heterogeneous mixture. Heterogeneous basically means that it's not the same the whole way through. You can take a random sample at a random time and it won't necessarily be the same as another sample taken at a different time in that mixture. You may see on the side of some milk bottles this word. The word homogenized tells you that this is a homogeneous mixture. A homogeneous mixture means that any sample you take at any time will have the same constitution and consistency as any other sample. Another example of a homogeneous mixture is a mixture of salt and water. Any salt-water mixture will stay the same, no matter how long you leave it. The reason milk is described as homogenized is that it used to be a heterogeneous mixture, and now it is a homogeneous mixture. They do this by mixing it really quickly under immense amounts of pressure, distributing the fat particles in the milk evenly, meaning that you don't get a layer of cream forming on the top of the milk if you leave it for a couple of hours. I've grouped these things on the board left and right like this for a reason. Over here, these things are described as pure. Pure means that there is only one type of atom or compound present in the container or in the substance itself. Any mixture, on the other hand, is described as impure, because there is more than one kind of element or compound present in the sample. Unfortunately, other than salt and aluminium, there was really no practical section to this video, although I'm hoping next week when I do states of matter that I have some really good practical stuff to show you. Thanks for watching. Like the video, subscribe to the channel. I'm planning to do these every week, so there's definitely more to come. Stay tuned. Safety first. Shiny.